So good evening students. Today again we will continue with the same chapter, symmetry. Here today we are talking about line symmetry and rotational symmetry. Those figures which shows both kind of symmetries like line and rotational both. Okay. So here you have already learned which is line symmetry and what are rotational symmetry. So here the first I'm going to explain you with the help of some examples. I'm taking a question of your book which is exercise 14.3. Second question. Draw wherever possible a rough sketch of a triangle with both line and rotational symmetries of order more than one. So now you know now what is order of symmetry or angle of symmetries and how to do this line and rotational symmetries. So here you can see that here I have taken a equilateral triangle because for an equilateral triangle it shows both kind of symmetries like line and rotational both. So first I am going to explain you about line symmetry. Okay, so here you can see that for an equilateral triangle where all the sides are equal, all the three sides are equal, it shows the line symmetry. Line, it means that this is the first, second and third which passes through the vertices and it bisect the other midpoint of that midpoint of the other side. Okay, so here you can see that how many line of symmetries are there. There are three lines of symmetry for an equilateral triangle, and it also shows the rotational symmetry. So suppose if I am taking an angle of rotation which is 120 degree and every time I am going to flip it, you can see that here with red mark I have shown here. If it is we have given it at 120 degrees angle, if I am going to rotate it, again I am going to get a same figure. Okay, so it means that three times it is you are going to get the same kind of figure, so that it also shows the angle of rotational symmetry is also, because after giving at a rotation of 120 degree, every time you are going to get the same kind of figure. So an equilateral triangle is showing both kind of symmetries, which is line and rotational both. Now here one more question I am going to take, where here the table is given where you have to fill up these spaces, right? So here different shapes and center of rotation and order of rotation and then angle of rotation which you have to find out. So here different shapes are given. So a square. So what is center of rotation? Center of rotation is actually a center according to which you have to rotate a particular object, right? So what is the square, the center of rotation for a square? Obviously, because you all knows that a square means that it is a quadrilateral which is having four equal sides, right? So if I draw a square like this, and these are the diagonals of it, and because all the sides are equal of a square, so diagonals, and there is one more property, the diagonals of a rectangle, that is square and rectangle, both are same. So that intersection point, this is the intersection point of this diagonal according to which I have to rotate it, and after a particular angle we have to get we are going to get a same kind of figure. So what is center of rotation for the square? It is the intersection point of diagonals. These are the diagonals and intersecting point. It means that at this point they are going to cut each other. So this is the intersection point, which is the center of rotation for it. Now next is what? Order of rotation. As you all know, four equal sides, so it always shows the four times you are going to get the same kind of figure. So order of rotation for a square is 4, and angle of rotation is what? 90 degree. How do you get this? Because angle of for a complete angle is always equals to 360 degree, and if divided by 4, then you are going to get 90 degree. So angle of rotation is what? Here it is 90 degree. Okay. So after rotating it this square at 90 degree, you will again going to get the same kind of figure. So angle of rotation for a square is 90 degree and order of rotation is 4. Similarly, now I am taking rectangle. So rectangle, it means that opposite sides are equal, right? These two sides are equal, and similarly these opposite sides are equal. Here also length of the diagonals are same, so that angle center of rotation is the intersection of point of diagonals. Again, order of rotation is 2. We have discussed about this in earlier classes also. So yeah, order of rotation is 2, so that the angle of rotation is 180 degree. Now for rhombus as you all knows that it is also a parallelogram where all the sides are equal. Okay, but all the sides are equal, and but the value of adjacent angle is not 90 degree, right? It is different. So here also, what is wrong for rhombus? Order of rotation is 2, and the center of rotation is again here intersection point of the diagonals. Intersection point of the diagonals is actually the center of rotation, and here order of rotation is 2 and angle of rotation is 180 degree. Okay, this is for rhombus. Now equilateral triangle, where you had discussed in this previous question also. For an equilateral triangle is again intersection point of the diagonals is its center of rotation, and order of rotation is 3 and the angle of rotation is 120 degree. Now for circle. Circle is all you knows that it is made up of so many points are there. So I am taking a plate according to which you can understand. Now here so many points are there, right? Which with the help of it we are going to construct a circle. So there are so many points. So what is that center of rotation of it? Obviously center of this circle. If I will mark it like this point is the center of rotation for a circle, right? So this center is actually the center of rotation, and order of rotation, you can rotate it in any angle. Every time you are going to get the same figure. So here order of rotation is infinite because there are so many points, and if you are rotating it like this, every time you are going to get the same kind of figure, right? So here order of rotation is infinite, and angle of rotation any angle, right? If you are moving it like this at any angle, you are going to get the same kind of figure. So it means that angle of rotation is what? Any angle is the angle of rotation for this circle. Now I am going to take the semicircle. So I am just marking like this. Now it is looking like a semicircle. I am taking the shaded part, right? This is the shaded part, which is the semicircle. I'll just consider this shaded part only. Okay. Now midpoint of diagonal, you all knows that a line which passes through the center is known as diagonal. So this is the diagonal of this semicircle, right? So this is the center point. So what will you do? Midpoint of diagonal, this is the diagonal, and midpoint of it is this center point. Obviously because diagonal passes through the center, so this is the center. Okay, so midpoint of the diagonal is actually the center of rotation for this semicircle. Now order of rotation, if I am going to rotate it like this, 90 degree, you are going to get this kind of figure. Is this same? No, obviously no. Then 180 degree, it is looking like this. This is also not same as the previous one. Now again 270 degree, I am just rotating it, and here it is not similar. Now what? I'm going to rotate it again. So now this is the same figure which we are assuming at the previous earlier, right? So this is same. So how many times? Only one time I am going to get this same figure after rotating it of 360 degree. So here order of rotation is what? 1, and angle of rotation is 360 degree, because after giving it a complete rotation, then only I am going to get the same figure. So that angle of rotation for a semicircle is 360 degree and order of rotation is 1. Okay, so like this you have to solve this exercise where you have to find out the figures for which and line symmetry and angle of line symmetry and rotational symmetry, both you have to identify in a particular figure. Okay, thank you.